Hey, and welcome back to the channel. This is video 2 in our series on radioactivity. And the usual reminders before we begin: eliminate any distractions now by closing social media and closing any open tabs you've got on your computer. And most importantly, make sure that when we give you some practice to do, that you do them, because that is what makes this channel different from others. You get a lot of practice to make sure you really learn the material properly. And if you don't do them, then you're not going to learn very much. In our previous video, we learned that some atoms or some isotopes of elements are stable, and that means that the protons and the neutrons are stuck together in a very stable way. There's not too much energy there, and they will basically stay like this forever. But some elements have isotopes which are not stable. We call them radioisotopes. There's too much energy going on, there's too much vibrations in the nucleus, and the number of protons and neutrons is too unbalanced. And what's going to happen eventually is these are going to break up. So what I'm going to do here is I'm going to begin by drawing a large atom with an unstable nucleus. So these orange particles here are protons. So we've got protons, and these, I'll pick a different color so there's a good contrast. These blue ones are neutrons. So we've got a large unstable nucleus here. So this is an isotope of an unstable atom. A few more just for good measure. Okay, so this is what we call an unstable nucleus. So there's a lot of vibrations here, there's a lot of energy, the protons and neutrons are too unbalanced. And what's eventually going to happen is the nucleus is going to break up. And we said we had a word that describes how this happens, that is random. It doesn't require any kind of trigger to make this happen. If you remember what that word is, I want you to speak your answer to the screen on 3. 1, 2, 3. Speak your answer now. Hoping that you said it's spontaneous. That word spontaneous means that it just happens. It doesn't need any kick or boost in order to get started. It just happens. It's spontaneous. So eventually what's going to happen is that a particle of some kind is going to be given out. So, sorry, I should actually use the same colors again. So obviously it's a particle. So a particle, what do we mean? Well, we mean some of the protons and the neutrons. So I'm not going to just name this right now. I'm just going to talk about a general particle. So sometimes a particle is emitted. We say emitted particle. It's given out. And this is usually accompanied by some electromagnetic waves. Electromagnetic waves. And what the electromagnetic waves do is they transfer energy away from the nucleus. So all that extra energy that was in there that was making this unstable, when the nucleus breaks up and a piece is kicked out, like this particle is kicked out, then you also get energy being released. Now this here, what's happening is called a decay event. There's a couple of ways of saying this actually, but this process of the nucleus breaking down, we sometimes refer to it as nuclear decay. So nuclear decay. Sometimes it's called a decay event. Sometimes it's just referred to as radioactive decay. So these are all ways of saying the same thing. Now, they all contain the word decay. Now, from your everyday language, you've probably seen that word before, and you've probably seen it to mean like when something dies and it starts to decay. That's another word for like rotting. It just means to break up. Okay, but we're specifically talking about an atom breaking up, the nucleus breaking up. So it's a nuclear decay or a radioactive decay or a decay event. What's important to note is that if a particle has been kicked out, then what's left behind is a different nucleus. The nucleus is changed because it doesn't have all the particles anymore. Some of the particles have been kicked out. Now, I'm not going to go and count them out exactly how many, but you get the message that there's now a different amount of particles in the nucleus. So we have changed the nucleus. Ah, Jesus, sorry, I keep deleting stuff by accident. Sorry, do you know what I'm going to do? I'm actually going to cleverly copy this nucleus like that. I'm going to make a copy of that, and I'm going to paste it over here. Aha. And now what I'm going to do is I'm going to take it and I'm going to rub some of the particles out. So rid of, okay, rub it. Come on, there we go, rub it. Okay, it's not playing ball with me at the moment. I don't know why that is. I'm going to pause the video and try and fix it. Okay, so now you can see we have a nucleus which is changed, and it's probably going to be a more stable nucleus because it's kicked out a particle. Now, if it's not more stable, if it hasn't become a more stable nucleus, well, then it will do another nuclear decay or another decay event, kick out another particle, and it'll keep doing that until it gets ends up being stable. Okay, so that is a nuclear decay. That's what we mean, is when an atom breaks down, releasing a particle and some energy in the form of an electromagnetic wave. Right, we're going to take a look at the specific types of radioactivity now, and the specific types of particles that can be released. So I'm going to, again, we're going to start here with a large radioactive atom. Okay, now, when this atom undergoes a decay event, one type of particle which can be kicked out of the nucleus is this. Sorry. Doesn't want to do what it's told today at all. Why it's doing this. Sorry about this. Pause it again. Fix it. Okay, so one type of decay that can happen is that the particle that's kicked out, one type of particle, is what we call, well, it's first of all, I'll tell you what it's made of. It's made of 2 protons, shown with the blue dots, and it's made of 2 neutrons. So it's a particle composed of 2 protons and 2 neutrons. This here is what's known as an alpha particle. Alpha particle. Alpha has the symbol like this. This is the Greek letter for alpha. So this is an alpha particle, 2 protons and 2 neutrons. Some of you might recognize this from an experiment using gold foil. It was Rutherford's experiment, and these were the particles that he fired at gold foil and that allowed him to discover the nucleus. Okay, but we're not going to just talk too much about that at the moment. Now again, an alpha particle is made of 2 protons, which I'm going to show with the blue dot. So we've got 2 protons, 1, 2, 2 protons, and each proton has a +1 charge. So that's going to give the total particle, the alpha particle, a 2+ charge because you've got 2 protons. The alpha particle also contains 2 neutrons. So there are the 2 orange particles, 2 neutrons. Now neutrons have no charge, so these do not contribute to the charge. So that is the alpha particle. That gives us an overall charge of an alpha particle is +2. There are no electrons to balance out the proton's charge. So that is an alpha particle, and it's the first type of radioactive particle or radioactive decay. So alpha particles are emitted from radioactive isotopes, and they have a +2 charge. What about their mass, the alpha particle? Well, we know that protons and neutrons have a mass of 1 each. So the 2 protons have a mass of 2. The 2 neutrons have a mass of 2. So the total mass of an alpha particle is going to equal to 4 atomic mass units. So 2 from the protons and 2 from the neutrons. Total mass is 4 atomic mass units. A really important note to make here is that every time a particle is emitted, whether it's this type of particle, alpha, or another type, that electromagnetic radiation is always given out. This is what we call gamma radiation. This is gamma radiation. Gamma radiation is not a particle, it is energy. So its energy gets transferred, energy is transferred away from the nucleus. So this wave, this gamma ray or gamma wave, carries energy away from the nucleus. Now, after an alpha particle is emitted, sometimes what's left behind will be a stable nucleus, and then it will stop being radioactive. But if it's not stable when an alpha particle is emitted, then sometimes it will do another alpha decay, or sorry, not alpha decay, another nuclear decay. All right, it's time to do some questions now. Okay, if you want to, actually, you could probably pause the video and make a note on alpha particles. So pause the video now, make a note on alpha particles and gamma radiation. So you can just copy down what I have there. All right, so you should only be watching the video if you have made notes on that. What I want you to do though is cover up them notes. You shouldn't be looking at the notes while you do the questions. And we're going to do some practice questions. Okay, so I want you to pause the video and do the questions now, please. Okay, so first of all, number one, where do alpha particles come from? Well, they come from the nucleus. That's probably not enough. If you stop there, you have to be a bit more specific. What type of atoms does it come from? What type of isotopes does it come from? Okay, so alpha particles come from the nucleus of radioactive isotopes. So they don't just come from any isotope, they only come from radioactive isotopes. What are alpha particles composed of? 2 protons and 2 neutrons. Draw an alpha particle and label its constituent parts. Okay, so this is what you should have. Color coding, 2 of one color and 2 of another color. Then you label them. So this here, this is proton, and this is neutron. You can give them a key if you don't want to use labeled arrows like this. Protons and neutrons, 2 protons, 2 neutrons, that's it there. What is the relative mass of an alpha particle? 4 atomic mass units. Well done if you got that right. What is the charge of an alpha particle? It's +2. An alpha particle is the same as the nucleus of what element? Okay, so that would be helium. Helium has an atomic mass of 4. It's got 2 protons and 2 neutrons. So well done if you were able to work that out by looking at the periodic table. If not, it's something to make a note of now, that an alpha particle is the same as a helium nucleus. What are the differences between a nucleus before and after emitting an alpha particle? Well, if you think about it, think about the nucleus, think about the atom, what's it lost? So how are the numbers of things going to change after it loses an alpha particle? Well, hopefully you can understand that it's going to lose 2 protons, so it's going to have 2 less protons. And what does that do to the element if it's lost 2 less, if it's got 2 less protons? Okay, pause the video and write about that if you haven't already. Okay, so obviously losing 2 protons changes the element because it's the number of protons that decides which element we're talking about. So we've got 2 less protons, it's not the same element anymore. And it's also going to have 2 less neutrons. Its mass will have decreased by 4. So there we go. The nucleus will have 2 fewer protons, so it's a different element, 2 fewer neutrons. Its mass will be reduced by 4. That's what the nucleus, that's how the nucleus is going to be different. All right, back to it now. We're going to take a look at another type of radiation. So sometimes it's not an alpha particle that gets emitted. Sometimes it's a different type of radiation, a different type of particle radiation. And what I'm going to do here is I'm just going to try and move this down a little bit so I can fit in this next type here. I'm going to put this down here like this. That's gamma radiation. And I'm going to continue this arrow down here. Okay, I'm going to fit this in. So another type of particle that can be given out is what we call a beta particle. So we give it the symbol, the Greek symbol. It's like a Greek B. It's like a B, but it's got a little tail on the bottom here. It's beta, and we usually give it a negative sign. This is what we call a beta particle. And its symbol is written just before beta particle here. This is the symbol here. Beta particle. Now again, listen, don't write. I'll give you an opportunity to pause and write it down, but just listen while I explain. Okay, so beta particle, what are they? They are fast-moving electrons. So just an electron. Fast-moving electrons. So what kind of charge do they have if they are fast-moving electrons? Well, if they are electrons, then they have a charge of -1. -1 charge. And their mass is the same as an electron would be. So it's 1/1838. That's its relative mass. Compared to a proton or a neutron, it's got 1/1838, or what we call a negligible mass. It's really, really tiny mass. Now, some of you may have questions about how exactly an electron can come out of the nucleus. I'm going to give you the short version now, and we'll explain it in more detail in a future video. But basically what happens here is a neutron spits out an electron. Now, I know that sounds crazy, but a neutron splits into an electron and a proton. So what it does is when a neutron converts or changes, it spits out this high energy electron, and then what happens is the proton gets left behind. So a neutron changes into a proton and kicks out an electron. Crazy stuff. We will do it in more detail later. But if you're wondering how does a beta particle come out of the nucleus if it's an electron, it's a different type of electron than the electrons you find orbiting the nucleus, okay? So that is beta particle. They are fast-moving electrons. They have a -1 charge. When I say fast-moving, I mean really, really, really fast. Hundreds of thousands of kilometers an hour they come out of the nucleus at. And obviously, they don't keep traveling forever. They'll start to hit and collide with like air particles or other materials around. And eventually they'll slow down and they'll just attach themselves to a new atom and become an orbiting electron on another atom. But again, we will explain that in a little bit more detail in a future video. Okay, all right. So what you can add now is beta particle. You can add that to your notes. Pause the video and do that. And again, we're covering up the notes and we're going to do some practice questions again. So here we have some questions. I want to pause the video and answer the questions. All right, answers are coming up. I think these should be pretty straightforward for you to just correct them yourselves. Different color pen, please, than what you've written in, either green or red or purple or something. And here are the answers. So pause the video and make any corrections to your answers now. Now, these aren't full answers, and I always ask you to answer in full sentences. These are phrases or things you should have in your answer. Your answer should be a full sentence. I'm just giving you the bits that you should have in there. So look for these bits in your answer. If you don't have these bits, then you should definitely add them in. All right, last task for you. We're going to practice some scientific writing now. So again, the idea here is that you write out the paragraph, but fill in the blanks. So don't just write the blanks down. You're not going to learn as much by doing that. The whole idea is that you get good at writing out a full, proper explanation. But the some of it is done for you to give you a skeleton or a scaffold on how to write a good explanation of radiation. So pause the video, write this out, fill in the blanks with the keywords that we've talked about in the video. All right, here are coming the answers. Again, you should have your pen out, red pen out for correcting, and you should actually make a point of ticking them off whether you had them right. And if you don't, put an X through it and write the correct word in red now. Okay, so here are the answers. Pause the video and make any corrections that you need to now. Okay, so you now know about the different types of radiation. One thing I want to focus on is, if I go back here for a second, is a big difference is where you have to state one difference between gamma radiation and the other types of radiation. Note, it's really important that you remember that alpha and beta radiation are actual particles. They are actual particles being fired out of the nucleus because the nucleus has too many of something on, it's unstable. So it fires out some particle. It's always accompanied by the energy, the extra energy that's in there that's making it unstable, also gets released and it's transferred away from the nucleus by what we call gamma rays, gamma radiation. Is energy transfer. It's bringing energy away from the nucleus. So it's definitely different. Energy and particles are two different things. So whenever an alpha or a beta particle is emitted from the nucleus, the gamma radiation is also emitted. Okay. All right, that's it, guys. We've learned about the different types of radiation. There will be more detail, and we'll be looking at these things, alpha and beta and gamma radiation, in a little bit more detail in future videos. But I hope you found this pretty straightforward. If you did, please give the video a like. It might help someone else to find it, and it might help someone else who's struggling with this concept to pick it up a little bit easier, give them lots of practice, and help them to remember it for the long term. Okay. Thanks again for your attention. It's good to see you all. It's good to see so many people enjoying the videos, I think. And I shall see you in the next video.